Okay, guys, so now we're on to the real deal, solving rational expressions with unlike denominators. All right, so this is a fairly straightforward process. The first thing you want to do is take a look at your denominators and see if any of them are factorable. This will help us determine like denominators in a much easier fashion. And the x squared minus 4 here is factorable into x plus 2, x minus 2. As I take a look at that denominator in connection with these other two, remember, we're in textbook land. Wow, what a coincidence. That's the denominators in the first two fractions. So what I'm going to choose to do is multiply through by these two like denominators, x minus 2 and x plus 2. Now, I'm writing them over each other, squeezed into the left side here because I'm a little tight for space on this particular board. But these are both right next to each other, and this is multiplication. Remember, as we're distributing, we're technically multiplying. And so we're going to multiply to all three of these terms. As we multiply at this level, hopefully we're able to sort of cancel out in our head as we distribute through. Writing all of this out step for step would really be an arduous process. So as we multiply through, we have x minus 2, x plus 2 times this first fraction. What's going to cancel out? The x minus 2 cancels out the x minus 2, and you're left with x plus 2 times 2x. Plus, you have a 1 over the x plus 2. The x plus 2 is going to cancel out the other x plus 2, leaving x plus 1 times, or x minus 2, I should say, times positive 1. So you got x minus 2 times 1 equals, and then in the last fraction here, these two binomials in the denominator will cancel out these two binomials, leaving us with just 1 times 10, or simply 10. The next stage, we're going to distribute each set of terms now carefully. So 2x times x is 2x squared, plus 2x times 2 is positive 4x, plus x minus 2 equals 10. At this point, I want to sort of bring up two things that we should be paying attention to. One, we have some terms that can be combined, and more importantly, we have a quadratic, which means if we have a quadratic, we want to set everything equal to 0. So I'm going to want to bring this 10 to the left side. I'd like to keep this 2x squared. I want to keep this 2 positive. I always want to keep that quadratic coefficient positive. So I'm going to leave this as 2x squared plus 4x plus x gives us a positive 5x. And I'm going to subtract 10 from both sides as I do this, leaving me with a negative 12 equals 0. At this point, I want to see if this is factorable, and most likely it is. So the first thing I want to do when I'm checking for factoring is to see if there's any common constants or a variable I could pull out, and there isn't. Because of this 5, there's not an x in any of the on all three of the terms, and they don't have any multiple in common. So I'm just going to go ahead and break into my double sets of parentheses and hope for the best. At this point, 2x squared, there's only one way I could factor 2, so that's going to be a 2x and an x, and when I FOIL, that will give me my 2x squared. Now I'm looking to put some factors of 12 here, such that when I FOIL this thing together, I get a positive 5x. So if you think about some common factors of 12, you got 1 and 12, 2 and 6, and 3 and 4. And now, some people like to go with splitting the middle term. I really feel that that's a major process of memorization, and really I want to just go with the guess and check method. It's served me well over time, and it helps me practice my multiplication tables. So perhaps we'll go with 3 and 4 sounds like a good idea. And if I put 4 here and 3 here, this will get me 3x, and this outer product here gets me an 8x. And lo and behold, the difference of 8x and 3x is 5x. I want that difference to be positive, so I want my 8x to be positive and my 3x to be negative. That allows me to put the negative sign there and a positive sign here. The last step is to take my two terms and set them equal to 0. Because this binomial times this binomial equals 0, then that means that one of these two, or both, must be 0. So I solve for both instances. and I get 2x minus 3 equals 0, and x plus 4 equals 0. I take each of these, and I finish solving, and I get x equals positive 3/2, and x equals negative 4. The last thing I want to do is just take a quick look back up at my denominators in my original function and decide, does either one of these or both cause this denominator to go to 0? So does 3/2 cause this to go to 0? Nope. How about here? Nope. How about here? 9/4 minus 4? No. How about negative 4? Negative 4 squared is 16 minus 4, not 0. And negative 4 in both of these spots won't cause those to go to 0. So, in the end, my final answers are 3/2 and negative 4. Hopefully that was helpful.